Welcome back, everyone. This is mini lesson number 9. We're going to talk about separation of variables and the initial value problem. This is section 5.5 in your book. Separation of variables. This is like implicit integration. It's all the variables must be done, all the variables must be together before you can integrate. They're all x's and y's mixed together. These problems are no different from the problems and examples I'm going to cover in class. I'm including this mini lesson because this was what last year's students told me that was the most forgotten topic on the AP test. Every one of them came back and said, the last problem was a separation of variables problem and I did not know how to do it. I froze, I blanked. Now half of them still got it right, so I don't know. But I'm taking the extra time today to make sure we get it. Every single year, there's at least one multiple choice and one short answer question dealing with initial value problems. Separation of variables. The separation of variables is a very important topic. On the separation of variables problem on the AP test, if you don't do the first step right, you get no credit. And that's why we're going to take some time to talk about it. Let's start off with an easy one. Separation of variables means let's cancel out this. Well, how do I cancel out a derivative? Normally, I would just integrate both sides. Why can't I in this problem? Because I have x's and y's all mixed together on this side. So, we're going to get all the y things on the left side, all the x things on the right side. This is divided, so I'm going to multiply it over. This is divided, I'm going to multiply it over. Now I've separated my variables. All the y things are on one side, all the x things are on another side. Now how do I cancel out a derivative? I integrate. How do I integrate this third power? I make it a fourth power, put a 1/4 in front. How do I integrate a squared? I make it a third power, put a 1/3 in front. And I put a plus c. Why didn't I put a plus c on both sides? Because algebraically, a plus c and a plus c would cancel each other out. I don't want them to cancel out. I want there to be 1 plus c left in this answer. That is why I put it over here. Doesn't matter if you put it over here and you subtract it over, it's minus c, but c means every number, so adding every number is no different than subtracting every number, it still means every number. Okay? Let's get y by itself. What's the first thing I need to do? Multiply both sides by 4. So I'm going to be y plus 4 to the 4th power equals 4/3 x minus 3 cubed. This isn't 4c. C is every number. Every number times 4 is still every number, so it's still c. How do I cancel out the 4th power? I'm going to take a 4th root. So 4/3 x minus 3 quantity cubed plus c. If you do that, you're wrong. You're missing something. I took a 4th root of both sides. I need a plus or minus. Final answer to get y by itself. Y equals plus or minus. Let's do it like this. Let's do -4 plus or minus square root of 4/3 x minus 3 quantity cubed plus c. And there's your answer. That's a separation of variables problem. And believe it or not, that one's pretty easy. Let's make it a little bit more difficult. You will see ones like this very, very, very commonly. The first thing I'm going to do is rewrite it. I'm going to rewrite it like this. dy over dx equals x squared. Now let's separate my variables. Let's get all the y's on one side and all the x's. If I move this y over here, I'm dividing by y, but I don't want to divide. That makes the problem too ugly. I'm going to multiply a 1 over y, dy. That leaves x squared, and I'm going to move the dx over here. Now all my variables are separated. All the y's are one side, all the x's are the other side. Let's cancel out the derivatives by integrating. This side's easy. 1/3 x cubed plus c. About the left side. What's the integral of 1 over y? Well, if I were to write this as y to the negative 1 and try to integrate it like I normally would do, that's, if I add 1 to it, I get 0, and then I get 1 over 0, and that doesn't work. So that's not the way to integrate that side. What's the integral of 1 over y? What has a derivative of 1 over something? Natural log, absolute value. When you integrate, it's got to be absolute value because you can't take the absolute value of a negative number. Now let's get y by itself. It looks tricky, but once you see it, it's the same every time. If it was addition, I would subtract. Back here, it was fourth power, so I took a fourth root. How do I cancel out natural log? What's the inverse of natural log? It's e. So I'm going to raise both sides to the e power. On the left side, the e and the natural log are going to cancel out, and I'm just going to get y equals e to the 1/3 x cubed plus c. That answer's fine, but that's not the way you will ever see it written. Let's talk about what this right here means. When you add exponents, that's the same thing as saying e to the 1/3 x times e to the c. Because if you were to put those two together, it would be add the exponents. This is e to the 1/3 x. This is e to every number. E to every number is still every number. So what symbol means every number? Just c. E to the c, it just becomes c. So what's my final answer? Y equals c e to the 1/3 x. And yeah, that's important. You'll see why on the next problem. Initial value problem. Let's separate the variables and then solve for this initial condition, the point 0, 5. Well, just like last time, this is going to be 1 over y minus 3 dy equals x minus 2 dx. How do I cancel out the derivatives? I integrate. This is 1/2 x squared minus 2x plus c. This side, 1 over something, is natural log of that. Just like last time, I have a natural log and I need to get rid of it. What cancels out a natural log? E to that power. So e and natural log will cancel out. I'm left with y minus 3 equals e to the 1/2 x squared minus 2x plus c. Using the same trick I did last time, I'm going to rewrite this as c e to the 1/2 x squared minus 2x. Because that plus c is times e to the c, which is c. So this is y equals c e to the 1/2 x squared minus 2x plus 3. Okay? That's as much as I can simplify it. And normally I would be done. But remember, they gave me an initial value in this problem. The initial value is 0, 5. So let's plug in 0 for x. And 5 for y. And the only thing I don't know then is c. So let's solve it. What's the exponent going to be? It's going to be 0. What's anything to the 0 power? It's 1. So c equals 2. Now write your answer. Y equals 2 e to the 1/2 x squared minus 2x plus 3. Separation of variables almost always looks like this, where you have an e to some power. The reason being is because it had to use a natural log. As always, guys, this is an example of a difficult problem. We're going to do a lot more in class. If you have questions, comments, or you don't get it, come see me before, after, or during study hall. Okay, thanks.